piece of machinery is capable of producing rectangular sheets of metal such that the length is 3 times the width. Furthermore, equal-sized squares measuring 5 inches on a side can be cut from the corners so that the resulting piece of metal can be shaped into an open box by folding up the flaps. If specifications call for the volume of the box to be 1,435 inches cubed, what should the dimensions of the original piece of metal be? Okay, so here's kind of a drawing. From here to here is x. From here to here is 3 times x. But I have 5-inch cutouts that we have to cut out of this. Because if you think about cutting these pieces out right here, that allows you to fold up the box to make a box and have some volume. So furthermore, saying that, if I'm cutting out those pieces, this side really truly, because I'm looking at this right here, is x minus 10, because I have to subtract this piece and this piece. Excuse me. This piece I'm looking at right here corresponds with this piece, so it has to be 3x minus 10. Now when we're looking at this piece right here, x, because it originally had these two pieces, minus 10. So let me help you. Volume. Volume is length times width times height. Well, I know the volume of this piece is 1,435. The length is 3x minus 10. The width is x minus 10. And the height is 5. So really truly from here, my goal is to solve this. So I can multiply in any order. I'm going to multiply those two, and when I do, I get 5x minus 50, and I have 3x minus 10. So I'm going to go ahead and distribute that. And when I distribute that, I get 15x squared. When I distribute that, I get minus 150x minus 50x minus, negative times negative is a positive 500. And let's shorten that up just a tad. I'm going to combine my like terms right there. And when I combine those like terms, I get negative 200x, 15x squared, plus 500. The other thing I'm going to go ahead and do is subtract this 1,435. So what I have right now is I have 15x squared minus 200x minus 935. To make my life just a little bit more easy, I'm going to divide by 5 on everything. And when I do that, I'm going to get the following solution. 3x squared minus 40x minus 187 equals 0. Now, I can try to see if I can factor this, but finding multiples of 187 times 3 is going to be rather difficult. So I'm going to go ahead and use the quadratic formula. The opposite of b plus or minus b squared. So 40 squared is 1,600 minus 4 times a times c all over 2 times a, which is 6. When I simplify the inside of my quadratic, I'm going to get 3,844 all over 6. So let's go a step further. The square root of that, I'm going to put in my calculator, and come to find out the square root of 3,844 is 62. So now I'm just going to solve this. I have 40 plus, 40, let's use the plus sign first. 62 over 6, and 40 minus 62 over 6. When I simplify the first one, I get 17. When I simplify the second one, I get negative 3.6 something, but I know it can't be negative. So I know that x equals 17. So if I want the dimensions of this, it's going to be 17 represents x. So if I'm looking at this piece right there, if 17 represents x, I have to subtract the 10, and I will get 7. So I have a 7 for one piece. Well, then I have to solve it there. 3 times 17 minus 10. So when I plug that in my calculator, I get 3 times 17 minus 10. I get 41, and I know the height is 5. So let's go ahead and label and then check our answers. If I take in my calculator 7 times 41 times 5, I get 1,435. So these are the dimensions to produce this piece of metal.